together for a minute?
What actions
Okay.
taken by these teachers across the grade levels seem to encourage students to think mathematically? In what ways are these effective?
Done, 'cause there was some question about it.
At the Ferris High School in Jersey City, New Jersey, a math teacher uses Pascal's triangle, along with combinations activities, to help her students grasp difficult concepts in algebra. Gina was a researcher in the Rutgers long-term study.
All right, so what I'd like you to do is go to your tables, to your groups.
On this day, Gina is giving her students a new challenge. If ice cream is served in bowls that can hold up to 6 scoops, how many different ways can the ice cream be served? The students start by assuming that they have no more than 1 scoop of each flavor. The groups of students apply their previous knowledge of Pascal's triangle toward this new problem.
So let's see, you're telling me that this is 64 different choices for bowls of ice cream, and you didn't have to write anything but numbers?
Mm-hmm.
Okay, so this is kind of valuable if it works. Let's say, can you tell me what each of these numbers stands for in terms of bowls of ice cream?
The students' previous work with pizzas and towers has led them to a central idea of Pascal's triangle, that the numbers within each row map to the subsets of possible combinations. For example, let's look at the 4th row of Pascal's triangle. When building towers 4 high, there are 4 towers with 1 blue block, 6 towers with 2 blue blocks, and 4 towers with 3 blue blocks. Likewise, every number in every row of Pascal's triangle corresponds to the number of possibilities in a grouping of towers. Added together, the sum of the numbers in each row equals the total number of combinations possible.
So that's no ice cream. What's this?
One kind of ice cream, one flavor.
Okay.
Then 2, 3, 4, 5.
That's 6.
So this
all
last
flavors.
one stands for all 6.
All.
Okay. So how many do you have altogether then?
6 in a row.
Just take it through. No, because you don't count that one if that one doesn't have no, right?
63. So that's 63. Track.
By not counting the empty bowl, the students come up with 63 possibilities.
You need more paper?
In the second half of the 80-minute block, Gina presents a new problem, where the order of flavors does make a difference.
The cones were delivered later in the week. The owner soon discovered that most people who order cones are particular about the order in which the scoops are stacked.
The problem is, how many different ice cream cones can be made using up to 4 scoops of ice cream by selecting from 6 different flavors?
So we gotta use like these flavors and like just use 4 instead of 6, right?
It says for this one right here that they like the different, like if it's vanilla over chocolate or chocolate over vanilla. But I don't understand it because we were supposed to double it or something.
Well, I don't know. What do you think? If you had vanilla and chocolate and vanilla, is that 2 different things?
It's the same thing, but you're just switching it around.
Okay. In a bowl, does it matter?
In cones.
No, but
In a cone,
cone
doesn't matter.
Yeah.
Well, to some of these people it does, okay? Let's think about 3 scoops now.
You can start with this one on top,
Okay.
and then like that, chocolate, the cherry, and this one.
Okay.
That's 1 cone.
Okay.
Then you can stay with that one, but instead of this one, reverse that.
Okay.
By looking at the number of possibilities, or permutations, with 3 scoops of 3 flavors, these students are making a solid first step to solving the problem. Extending the work to 6 flavors, and including all the other possibilities, 1 scoop, 2 scoops, and so on, will eventually lead to the solution.
So it's kind of like when we did the towers, right? Like if you have 4 high and it's all yellow, and then you put 1 blue, so you keep moving it down.
That's a possibility. As we move through the combinatorics unit, every problem builds on what they've done before, but there's always a new wrinkle in it. What happens, for example, today with the cups and the cones? Well, what about this new wrinkle now with the cones? Let them think about something new, let them build on what they've already done, and then learn to express themselves. Write down something and think about it. Okay,
yeah.
oh, what do you
There's
think
3
about
more
that? Oh, I see what
flavors.
you're saying.
So you get 3 more, 6 more out of that, so it's 12 altogether.